Okay, final bit of the Radians chapter, chapter 5 from Pearson's book 2 for A-level maths. There's a small part towards the end of the book about solving trig equations using radians. It's exactly the same as solving trig equations using degrees. Just make sure your calculator is in radians rather than degrees, and also make sure using your ACTS diagram or graphs of trig functions that you get all the solutions, not just one solution, but get all the solutions in whichever quadrant they happen to be. The very last part of the radians chapter is about small angle approximations. This only works if your angle is in radians, which is why it falls in the radians chapter. And what it's looking at is what happens if the angle is very small. So on a sine curve, here's a sine curve. We're only going to deal with very small values of theta, so I'm not going to draw the complete sine curve. I'm just going to draw a little bit for when theta is very small. And if you want to do this on Desmos or KBA or whichever graphing program you want to use, then please do and compare the graphs. If I draw sine and I keep my axes square, in other words, I'm going up here by the same amount that I'm going up here. So for example, that would be 1, because sine doesn't go any further than 1, and this would be 1 radian. You'll find that when theta is very small, so just about here, sine looks a little bit like that. And you'll say, well, that's the same as the y equals x curve. Absolutely right. When theta is very small and is measured in radians, then sine theta is almost the same as, obviously it's not y equals x, we're not using x, I'm using theta. It's almost the same as y equals theta. They're about the same when theta is very small and measured in radians. Tan also, if you were to draw tan, for theta being very small, obviously it comes down here along there and goes up, sort of bends up and bends down. But when theta is very small, very near the origin, it looks very similar to sine theta. It's about the same as theta. Now you are told these in the formula book. Okay, so you don't need to remember them, but they're worth remembering, worth certainly knowing that they exist. So sine theta and tan theta, when theta is very small, are about the same value as theta itself. Try it out. Set your calculator on radians, put in a very small value for theta, so 0.01, and see what sine of 0.01 is. And you'll see it's very close to 0.01. Same with tan. Cos is a little bit different. If you recall that cos, when theta is very small, near the origin, cos is actually up here, and it sort of comes down there and comes down like this. Clearly that's not the same as theta. Theta would be along here somewhere. But it does look a little bit like a quadratic. And it's a quadratic that goes through 1. And it's a negative quadratic. So it could look something like minus theta squared plus 1. So minus x squared plus 1 if you like, but we're dealing in angles, not in general variables. So that's why I've got theta here. It's a bit like that, but if you plot it on Desmos, you'll see, yeah, it's fairly close to this, but if you make your quadratic minus theta squared over 2, you'll find it's very, very close indeed. So we tend to write it as 1 minus theta squared over 2. This is your small angle approximation for cos. Sine and tan are quite straightforward. They're both about the same as theta. Cos is a bit more tricky. This is a small angle approximation for cos theta, for when theta is very small. So if you want to use this instead of that to work out the value of cos theta, you may do so if theta is in radians and it's very small. Okay, let's see how this can work. So this is a question taken from the textbook. We're going to work out an estimate for this. Cos 4 theta minus 1 over theta times sine 2 theta. For when theta is very small and is in radians. Well, this is approximately equal to. Okay, This is where we need to use our small angle approximations. Cos 4 theta. Well, cos 4 theta, instead of having theta here now, we've got 4 theta. This is the small angle approximation for cos. So this bit here is going to be 1 minus, not theta, but 4 theta. So it's going to be 4 theta squared. Make sure you deal with the whole of this angle. Over 2. Take away 1 over theta times sine 2 theta. Well, sine 2 theta, when theta is small, approximates to 2 theta. Right, let's tidy this up a little bit. 1, take 1 is 0, the 1's cancelled. So I've got 16 theta squared over 2. And it's negative. So minus 16 theta squared over 2 divided by 2 theta squared. Well, let's deal with the numbers first because this is a bit messy. Minus 16 over 2 is minus 8. Minus 8 divided by 2 is minus 4. And theta squares cancel. So this thing, when theta is very small, approximates to minus 4. Try it, make theta very small, 0.001 or something, but cos of 4 theta take 1, divided by theta times sine 2 theta, and you should get an answer that's pretty close to minus 1. I'm going to do one more example. Sine 5 theta plus tan 2 theta minus cos 2 theta. We're going to work out a small angle approximation for this when theta gets very small. Okay, so sine 5 theta, well, a small angle approximation for sine theta is just theta, so for sine 5 theta it would just be 5 theta. Similarly for tan 2 theta, that would just be 2 theta. And here comes the tricky one, cos 2 theta. Okay, there's my small angle approximation for cos. Let's put it in a bracket, make sure we get everything correct. 1 minus theta squared, so this angle squared. Our angle is 2 theta, so make sure we got 2 theta in a bracket, divided by 2. So sine 5 theta plus tan 2 theta minus cos 2 theta is approximately equal to this when theta is very small. And that's equal to, okay, we got 7 theta minus 1 plus 4 theta squared over 2, which is 2 theta squared. When theta is very small, or when theta tends towards 0, this thing is going to tend towards 0. 7 lots of 0 is 0. 2 lots of 0 squared is 0. So as theta gets very small, as it tends to 0, this tends to 0, this tends to 0, and we are left with minus 1. So this expression here, as theta tends towards 0, becomes minus 1. The small angle approximations, try and remember them, but you are given these 3 things in the formula book. You do not need to remember them. Sine and tan, really easy. Cos, a little bit more tricky. The error that students make here is substituting this angle into this expression. If this is 7 theta, then you need to square the whole of 7 theta. Good luck with those. That's radians.